Hey, what's up, guys? Chung here again. So this time, let's take a look at another LeetCode problem here. Number 309. Best time to buy and sell stock with cooldown. You know, in LeetCode, there are like a series of buy and sell stock problems. There's like about buys and sell stock 1, 2, 3, 4, and then with transaction fees, and then this time with cooldown. So this is like you know, for all this kind of serious problem, they're all like very classic DP problems. And I think today I just want to maybe introduce like a no-brainer, like a generic way of solving this kind of problems. You know, basically the key concept for all this kind of buy and sell stock here is that I think, at least for me, the best way to solve this problem is we're gonna have like a two list here. Basically, we're gonna have a buy list, and then we're gonna have a sell list. So this buy and sell, what does this mean? It means that by the time, by index I, and the last transaction is buy, and the maximum profit. Because for all this kind of buy and sell stock problems, it always asks us to calculate the maximum profit, right? And same thing here, right? Same thing for the sell. So by index I, the last transaction is sell, right? And what's the and the max profit. Okay, so so with that, let's take a look at how can we use this buy and sell to formulate our state transition function here. And for buy, right? So for current buy here, uh, how many options do we have here, right? So at the current buy, we can either don't do nothing, right? Basically, we just don't buy or don't sell. We just stay the same, right? Then it's gonna be the same as the buy I minus one, right? Since we're not doing anything here. And remember, so that's why the last transaction in this case is still buy, right? And that's why we are gonna inherit the max profit from the buy I minus one. Okay, so that's the first options we have here. And what's the second option? Because remember, so this buy I here, right? We still want to buy it here, right? Because here it's the buy I here stores the last transaction is buy, right? So basically we only have two options. Either we don't buy it here, or we want to buy it here, right? So let's say if we want to buy at current I here, what do we need to do here? So in this case, we have to sell sell it first. But the only difference here is instead of doing a sell, sell I minus one, because in this case, remember, we have a cooldown here. The cooldown is 1 day, which means after selling a stock, we cannot buy it until the 2 days later. That's why instead of a sell I minus one, we have to do a sell I minus two, because we only if we sell at I minus 2's day, then we can buy it at the current day, right? And then we sell it, and then so to buy it, we have to decrease the prices, okay? Because to buy a stock, we are spending the money, right? So basically, that's the state transition function for buy dp buy I, and then for the sell I, same thing, right? So for the sell, we can either choose we don't sell, right? That means the last sell is still in the so if we don't sell it here, or we don't buy it here, we don't sell it here, so we just need to inherit from the sell I minus one. Or if we decide to sell at the current one, It means we have to buy it at the I minus one, right? I minus one. And then to sell it, we are earning the money. We're earning the current money. And then in the end, what's gonna be our final answer? So in the end, we need to return the sell, okay, assuming we have a n equals to length prices. Okay. So what's gonna be our final state? So the final state, regardless of when do we sell or buy, or where do we sell or buy, the last statement should always end up as selling a stock, right? Because we don't want to end up with a stock stuck in our hand without selling it. That's why the sell n minus 1 will be our result, because that means at the last index and the last selling and the last transaction, it sell what's the max profit we can get. Okay, so with this kind of buy and sell state transitions, in our case, this is just like the in case it's going to be I minus 2. If there's no cooldown time, we can simply change this one from I minus 2 to I minus 1. But in this case, we have to handle the cooldown with this state here, with this change here. And since we have this state transitions, all it's left, we just need to do some corner case checking or the base case, right? So first, let's do a 0, okay, with n, right? And sell 0 with n. And as you can see here, since for the sell, so since we're going back at minus 2 here, so that it basically it tells us we have to start with 2 to the n, right? Otherwise, if we don't start at 2 here, when we start from 0 or 1, this I minus 2 will be out of the boundaries, right? At least, so since this I minus 1, we can simply start from 1, but since we have this I minus 2 here, we need to start at 2. So since we're going to start at 2 here, we have to basically initialize the 0 and 1 case. Okay. Okay, so what's gonna be the buy 0? So with buying at 0, so basically the buying 0 is obviously we just buy the first stock, right? That's gonna be our max profit. That's gonna be minus prices 0, right? How about buy 1? What's the buy 1 here? So buy 1 means at the index 1 here, what's gonna be the max profit if the last transaction was a buy transaction. Basically, in this case, it's gonna be either we buy at the 0 or we buy at the 1, right? So we only have those two options. And then we just need to get the max of them, right? So the max of them is the minimum of the negative buy prices 0 and the price is 1. Since for buying we're spending the money, and that to get the maximum from it, I'm getting the smaller absolute value, right? For those, I'm getting the smaller prices we need uh, prices since we're going to spending that money, okay? And then the sell, right? So for sell 0, of course, sell 0 is 0, right? Because if we sell at 0, it doesn't make sense because the you don't have you haven't bought any stock yet, so that's why you cannot sell, and that's why sell 0 is 0. How about sell 1 here? Right, sell 1 means we just simply it's very simple, right? So to be able to sell at 1, we have to buy at 0, right? So basically that's where the price is 1 minus price is 0, right? But since we're getting the max of them, and there's one more things we need to be noticed here. So the minimum sell, the minimum, right? Basically, the minimum profit we can get is always 0. It's always going to be 0. Why is that? Because no matter how basically think about in this way. So let's say no matter how this price is fluctuated, we can always don't do anything, right? Basically, we don't buy and then we don't sell. We just watch the prices changes until to the end. Then our sell, basically the sell max profit can should never go down to 0, go below 0. That's why we have to set the boundaries with 0. So what this one is telling us is that I'm not allowing my sell DP to be smaller than 0 because I can always choose not not buy and sell, right? And that's basically how I initialize this two 0 and 1, and then all it's left is just I simply copied these two here, right? That's what I'm going to do here. And then in the end, I simply return the cell and minus 1. Did I? Oh, here. Yeah. Okay. I think I can just return it. Run it. Okay, cool. This accepted. Let's try to submit it. Oh, sorry. Yeah. So, I mean, because we are assuming, see, so we are assuming since we're using 0 and 1 here, basically we are assuming there are at least two prices in this list here, and that's why we have to do a check. Basically, if the n is smaller than 2, which means if there's only one price or no price, what's going to be the return? Okay, so first for the if there's no price, of course, the max profit will be 0. What about with one price? Same thing, right? So with one price, the only option we have is we don't buy it because you are not allowed to buy and sell the price at the same day. And if you buy the price and you don't have any days left to sell it, you're ending up spending, basically you're ending up spending that stock, but never got a chance to sell it. That's why when the n is smaller than 2, we'll always return 0 here. And let's try to submit it one more time. Cool. Yeah. So pass. And basically, okay, just to recap these things here, I'm just introducing a very generic way of solving this kind of buy and sell stock problem. Basically, we will just define like two arrays here. One is for buy, which means stands for by the time at I, by index I, and the last transaction is also buy. What's the max profit? And then for the sell, same thing. By the index I and the last transaction was sell. what's the max profit, and then we can simply come up with this state transition method. And then the only thing in this, uh, the only cases we need to take care of first is about this two base cases, since we are going back to I minus one. That's why I'm going to start with two here. And as you can see, so the time complexity for this is obviously O of n, and the space complexity is also O of n. And you know, uh, to improve, we can since you guys can maybe already have figured out yet how or have found it, since the current DPI since we are going to have like two DPs, right? So anyway, so the current DPI will only depend on three variables, right? Which means it's a constant previously state, right? So in that case, we can always compress the space complexity from ON to O1, right? Basically, we're gonna have like a rolling state to basically to keep updating each of the state here, right? Space, yeah, as you can see here, we have the prices I here, and actually all we need is we just need uh, three. We just need the three state variables like buy I minus one and sell I minus one and sell I minus two. All we need is these three variables to be able to calculate the current one. So we can just define like three variables here, and then we updating it. Basically, every time we update the I minus one variables to the I minus two, and the current by I to the I minus one, and so on and so forth, right? I'm gonna leave that to you guys to implement if you guys are really interested in how can we reduce the time space complexity from O of n to O1. Basically, you just need to use three three variables, yeah, and then keep updating it while you're doing the for loop. Mm. Yeah, I think cool. I think that's pretty much I want to talk about for this problem. So remember, for all this kind of sell and buy and sell stock problems, for me, at least for me, always try to use this buy and sell a list first, and then come up with this kind of transition, state transition functions, and then and in the end, always sell the last one. Okay, cool. Thank you so much for watching the video, and see you guys soon. Bye bye.